NASA's Artemis program, together with the Lunar Gateway, is laser focused on getting humanity back to the moon. But this time around, unlike the Apollo missions, NASA is teaming up with private companies for much of the hardware and expertise. Living on the moon, however, is a whole different ballgame compared to life on Earth. Imagine dealing with lighter gravity and a complete lack of air. Yep, the moon is one tough customer. There's no atmosphere, no weather, and no oceans. Just a vast, airless expanse. So far, astronauts have only managed to stay on its surface for up to 3 days, cooped up in the cramped lunar module during the Apollo missions. But what would it really be like to call the moon home? Stick with us till the end, and we'll unveil all the surprising details. Space exploration has always had a fascination with the moon, Earth's ever-watchful companion. In 1959, a Soviet spacecraft gave us our first glimpse of the moon's mysterious far side. And just a decade later, in 1969, NASA made history by landing humans on the lunar surface. Since then, countless missions have followed, like NASA's Lunar Reconnaissance Orbiter, which delivered the most detailed lunar topographical map ever, covering 98.2% of the moon. However, despite these groundbreaking missions, the data tells us one thing. The moon is a tough place to call home. Lunar days stretch to about 14 Earth days, with scorching temperatures hitting 253 degrees Fahrenheit, 123 degrees Celsius. Then come the equally long lunar nights, plunging to a bone-chilling minus 387 degrees Fahrenheit, minus 233 degrees Celsius. Living on the moon would require some serious insulation. Imagine a city under a transparent dome, offering breathtaking views of space. Sounds fantastic, right? But the reality is tricky. The dome would need to withstand extreme temperatures and likely be built from materials either shipped from Earth or manufactured on the moon itself. A colossal challenge. A more feasible solution might be constructing low, dense settlements and burying them under lunar regolith, the dust and rocks covering the moon's surface. This layer would act as a natural insulator, and mixing it with a binding agent could create a concrete-like material. One of the most promising locations for a moon base is the lunar South Pole. This area boasts a vast reserve of water ice and a relatively stable temperature around 32 degrees Fahrenheit, 0 degrees Celsius, making it an ideal spot for setting up a lunar settlement. And imagine taking a vacation away from the lunar outposts and exploring sites unlike anything on Earth. Picture this. The moon's vast lava plains are adorned with towering impact-borne mountains, the tallest standing at an impressive 3.4 miles, 5.5 kilometers high, about the same height as Mount St. Elias on the border of Alaska and Canada. Then there are the intriguing skylight holes scattered across these plains, where ancient lava flows likely drained into underground caverns, perfect for adventurous lunar spelunkers. But the moon's wonders don't stop there. Huge craters like the 25-mile-wide, 40-kilometer Aristarchus crater, offering breathtaking views. Standing on the rim of the Aristarchus would dwarf the Grand Canyon and make Arizona's meteor crater look like a tiny golf hole in comparison. However, lunar living isn't just about marveling at the sights. We'd need serious protection against meteorites and solar radiation. Unlike Earth, the moon's atmosphere is practically non-existent, with just 100 molecules per cubic centimeter compared to Earth's 1 billion. Plus, the moon lacks a magnetic field to repel solar winds, meaning any attempt to thicken its atmosphere would be quickly undone. And then there's the issue of gravity. The moon's gravity is only about 15% as strong as Earth's, half that of Mars. This weak pull raises questions about its effects on human bodies. On Earth, the longest anyone has spent in orbit was 437 days, achieved by Russian cosmonaut Valery Polyakov. His mission was to study the impacts of prolonged microgravity on the body. Remarkably, Polyakov didn't suffer any lasting performance impairments upon his return, suggesting that life in a lunar city might just be feasible. However, while the moon offers spectacular views and thrilling adventures, ensuring our safety from the elements and understanding the long-term effects of low gravity are crucial for making lunar living a reality. Now, the beauty of the moon compared to Mars is that we don't have to commit to a lengthy stay. A trip to Mars means a minimum of 2 years on the surface, plus the round-trip transit time. We have no idea what that extended stay will do to a person, and once you're there, you're stuck. But with the moon, while we might not be able to stay forever, living there for a year at a time seems quite feasible without any serious harm. Here's an intriguing fact. We can actually get oxygen from the moon's surface. Lunar regolith, the moon's soil, contains about 1.4 tons of minerals per cubic meter, including about 630 kilograms of oxygen. Considering humans need about 800 grams of oxygen daily, 630 kilograms would keep one person alive for roughly 2 years. Pretty cool, right? We can extract this vital gas using electrolysis. Plus, there's a decent water supply up there. Water ice likely exists in craters, delivered by asteroids and preserved by the shadows. We can also extract water from the regolith by heating it to produce water vapor, which we can then condense into liquid. And yes, astronauts will continue the time-honored tradition of purifying urine into drinkable water. It might sound gross, but that's just the reality of space life. Astronauts drink pee. Deal with it. Now, let's talk about food. NASA has discovered that their packaged dry foods lose vital nutrients over time. While we could still get the calories needed, we'd start lacking in essential vitamins, leading to issues like scurvy. No one wants to deal with scurvy on the moon, so growing fresh plants is crucial for long-term health. NASA is already experimenting with growing plants on the ISS, and leafy vegetables are thriving. These greens would be enough to cover our nutritional bases. Finally, there's the technology we depend on. Communication will be crucial, not just for sending and receiving important information, but also for keeping people sane. We need reliable ways to make video calls, live streams, and stay connected with Earth, ensuring that those on the moon still feel like part of the human race. Now, imagine stepping onto the moon and setting up a base. What would it look like? Moonies living in hobbit holes. Our lunar digs will need to be tough as nails to handle the moon's extreme temperatures, lack of oxygen, meteorite strikes, and relentless solar radiation. Picture this. Early shelters will be fashioned from landers buried in craters covered with a protective layer of moon rocks and dust, thanks to robotic excavators. Entryways would resemble hobbit holes, with airlocks hidden in mounds, giving our lunar habitat a touch of Middle-earth charm. Portable power plants, the future of lunar energy. To keep the lights on, NASA's working on compact nuclear reactors the size of trash cans. While some parts of the lunar South Pole, like Shackleton Crater, bask in near-constant sunlight perfect for solar panels, early settlers will need a more reliable power source. Enter the mini-nuclear reactor, a block of uranium-235 fuel the size of a paper towel roll, capable of generating heat to boil sodium at a scorching 1600 degrees Fahrenheit. This heat will power a Stirling engine, converting it into electricity, ensuring our moon base stays powered up around the clock. Moon Ubers, getting around in style. Transportation on the moon will be a breeze with the Jet Propulsion Laboratory's all-terrain, hex-limbed, extraterrestrial explorer. Athlete. This robotic vehicle, with its 6 articulated limbs, can grip cargo like a pair of strong movers and navigate over rough terrain. Equipped with quick connect, digging, and gripping tools, Athlete will handle everything from transporting goods to shuttling passengers to and from the launch pad. Think of it as the ultimate lunar Uber. Mining ice for fuel, the key to Mars. The moon's low gravity, just 1/6 of Earth's, makes it an ideal launch point for Mars missions. Even better, it has ice, which can be turned into hydrogen-oxygen rocket fuel. Water is the oil of the solar system, after all. Using tools like the regolith, as mentioned above, and ice drill for exploration of new terrains, Trident, we can drill into ice-cemented regolith and rock to extract this precious resource. Robotic systems will then process the fuel and transport it to an orbiting gas station, ready for rockets heading to Mars to refuel. Now, what if you try your favorite sports on the moon? With gravity at just 1/6 of Earth's, every game will be a whole new ballpark. A lunar athlete could leap and throw a ball 6 times higher and farther than here on Earth. For instance, if you're into American football, get ready for some serious distance. The goalposts would need to be 600 yards apart instead of the usual 100. Now that's a game changer. But here's a cool twist. No need to check the weather forecast. The moon's atmosphere is so thin that there's no weather at all. Every day is a sunny one with zero chance of rain. However, you'd have to watch out for space weather. Picture this: golf ball-sized meteorites zipping around and highly charged particles from solar flares. Keeping an eye on the sky would become a vital part of moon life. And just when you thought you'd escape Earth's quakes, think again. The moon has its own version, called moonquakes. Data from seismometers left by Apollo missions show that the moon is still shaking, with rare quakes lasting up to an hour and hitting 5.5 on the Richter scale. These tremors could cause significant damage, so your lunar house better be up to code. So, what do you think? Is the moon a prime spot for our next colony? Share your thoughts in the comments below. If you enjoyed this video, give it a thumbs up. It really helps us out. Don't forget to subscribe for more fascinating space content. Thanks for watching.